vary, things differ a little bit from each other. So there's a couple different types of variability that we are going to need to know the vocab word for. And so in this first scenario, there's a physics class dropping an egg off the roof of a school to see how long it takes to fall to the ground. Everybody in the class has their own stopwatch. So when they drop it, they all hit start. And when it hits the ground, they all hit end. Are all their stopwatches going to say the same thing? Of course not. Why? Right. Just they should all be in the ballpark, right? Unless someone's really slow, or just, theirs doesn't work the first time. But that's called measurement variability. It's just in the way that someone measures. If I asked you all to measure the length of the width of the door with a ruler, you would all have, some of you might have the same answer, but you'd all might have slightly different variations, and that's just called measurement variability. So understanding that differences in outcomes that you might be studying could be different because just the person measuring from one person to the other would be different. Scenario 2 is these participants, 10 of them, forced to eat the exact same diet and exercise the exact same amount in a study of weight loss. Will each of the 10 participants lose the same amount of weight? Of course not. Why? What's that? There's other factors about an individual that you can't make all the same. Like these 10 people's different metabolisms, right? And you said the same thing essentially, right, Maggie? So this is just going to be called natural variability. There are always going to be natural characteristics of a subject that are going to play a part, that you can't neutralize everything. Obviously, we've neutralized the diet by making them all eat the exact same meals and the exact same amount of exercise. Okay, you can neutralize as many things as you really can, but there's always going to be these certain factors that are untouchables that you can't. And so that's just natural variability. Scenario 3. 100 participants are split into 2 groups of 50. Group A sleeps from 10 p.m. to 8 a.m. and wakes up to take a memory test. Group B is kept up all night and takes the same memory test in the morning. Will the groups perform the same? Of course not. Which group is going to perform worse? Why? Right. They were withheld sleep. So, our best guess is that that's what is going to be our outcome. Does that mean that someone in Group B, someone who is up all night, can't outperform someone in Group A? Right, of course they could. It's probably not going to be the general pattern, though. Right, the general pattern is that if you were withheld sleep, you're going to do worse, is our guess. What causes Group B overall to perform worse than Group A overall? Right, something that you placed on that group as a conditional, right? You induced that treatment that probably caused that outcome. So this is going to be called induced variability. And that's something that you kind of forced to happen by forcing a treatment on someone or people in general. And then the last one, 10 students are randomly chosen from the cafeteria and asked what their GPA is. So let's say we pick every 5th person that walks into the cafeteria, take their GPA, average them together. We do that one time. We get an average of 85, let's say. And then we just repeat. So we'll take every 5th person that walks in again and take those 10 people's average GPA. Will it also be 85? Probably not, right? Why would that be? Why won't it be exactly 85 again? Or why will it probably not be? Right, it's just kind of luck of the draw. right? Just the luck of the draw of the sample that you took, should they be close? I would think they would probably, over time, you would find that they are, every group of 10 that you get is going to be somewhat decently close to each other. You might have an outlier where you just happen to pick, the strongest kids in a class, and you just got a genius after genius after genius, and you got a very high GPA, but that would probably be an outlier. This should be a nice way of getting a random sample, yet they still won't be exactly 85 every time. And that's just called sampling variability. It's just luck of the draw. The sample that you happen to grab the first time might be slightly higher than the sample you happen to grab the second time. But if you did this 100 times over, I think you would find a nice overall average, right? If you did this experiment 100 times and averaged those 100 averages, now you're probably talking about something that's fairly close to the average of the whole school. Yes? All right, and so that's kind of what we're getting into. You see, I will also give this disclaimer about you learning statistics and also me teaching it. I will often have to slow down and pick my words very carefully, right? And be very picky about what word I choose. And likewise, you should be literally hanging on to every word that I say. And if you ever want me to stop and repeat that, can you say that one more time? Do it, right? Because it takes time to process. And there are some phrases that I'm used to saying pretty quickly that as you're first learning them, you're like, wait a minute, what does that mean again? Like, the average of the averages. Like, that takes a moment, right? That example that I just gave you of taking the average of that first sample of 10, then taking another sample of 10 and taking that average, and then taking a third sample of 10 and taking that average, and then averaging each of those averages. Do you follow? So as we move forward, we'll just say average of the averages, which when you first hear it, wait, what does that mean? And now when I slow it down, you can kind of take some time to wrap your head around it. So if you ever need me to repeat something, definitely speak up and slow me down, because otherwise your head will spin. You really want to make sure you're hanging on to every word. Again, this is more of a reading chapter than it is a math chapter. Okay, and then there's sampling and different ways that we can study things, okay? Every sample that you should take in statistics should be random, right? It should not be, if I wanted an average GPA, I shouldn't go to my advanced pre-calc class and grab 10 of those kids, right? That wouldn't be very wise. That's not going to give me a good representation of the whole school. So that would not be random. That would carry a bias with it, right? Because I've chosen from a group who is more likely to have a higher GPA for whatever reason, okay? Maybe they're naturally more smart, maybe they're naturally more motivated, always, sometimes a combination of both things. But that would introduce bias into the situation. So I want you to write, be careful of sampling bias. You've heard that word bias, right? B-I-A-S. But ways we can study. These three scenarios below are the three main different types of studies that we can do. The first one, if we're trying to get a feel for the most popular TV show, 20 students are chosen in the cafeteria and asked to report their one favorite TV show. Now again, this should be done randomly. We shouldn't go up to a single table or two tables right next to each other and ask those 20 kids, because they're probably friends, and they're probably friends because they have the same interests, and so they probably watch the same TV shows. What we should do is go to all of the tables and grab one person from every table and take a what? What are we doing if we're doing this? This is a word you use all the time. A survey, absolutely. When you go around and just ask people randomly, you're taking a survey. So if you see the word ask, and especially when you're asking like an opinion of some sort, like a favorite, not always, but lots of times, that's a survey. In scenario 2, you're studying the differences in income level from state to state. So you pick 100 people supposedly randomly from New York and 100 people randomly from Massachusetts, and you ask them to report their income, right? And then you're going to average the 100 from New York and you're going to average the 100 people from Massachusetts, and you might see that the New York average is $10,000 higher than the Massachusetts average, or vice versa. I have no idea. What you're doing there is just observing a fact, right? This is called an observational study, and I'll talk more about it in a minute. When I get to number 3. 3 is that same sleep study. I just copied and pasted it from above. If I force a condition on somebody, I'm forcing you guys, I randomly split you up, I'm forcing this group not to get sleep, and I'm letting this other group sleep as they will. I'm forcing a condition on a certain group after I've randomly split them into groups. What is this called, scientists? Experiment. Yep. Do you see the difference between an experimental study versus an observational study? You see, I can't do the state income one experimentally because I can't force people to live in New York and see then how they fall, right? So what you get here is correlations more so as opposed to cause and effect, potentially. Experiments can help us see cause and effect. Did that sleep study cause that thing? I can't say that living in New York caused people to make more money. There's so many other factors that I haven't controlled, versus here I've controlled as much as I could to see if that specific treatment did something to those people. Nathan. Perfect, right? There's control here. And there's manipulation, controlled, and lots of times they're called controlled experiments, right? Yes, and you manipulate something. You try to keep everything the same between two groups except for one thing. So you try to eliminate as much natural variability as possible, right? And by keeping as much the same as possible, and by randomly, putting people into two different groups, you are trying to isolate that only one difference is probably what caused the difference in outcome. Okay? So, surveys, observational studies, experiments. And with that, we go to these questions. A school cafeteria has 5 different lunch periods. The cafeteria staff wants to find out which items on the menu are most popular. So they give every student in the first lunch period a list of questions to answer in order to collect data to represent the school. Which type of study does this represent? Certainly not an experiment, right? Then, were we observing? No, right? We weren't observing the cause that something might, the correlation between two factors. We were surveying. Now, were we surveying the entire population or just a sample? Just a sample. We just did the first lunch period, so that's just a sample of the entire school. They're trying to figure out which items on the menu are most popular for the school as a whole, you would assume, right? In order to really find out, you would have to ask the entire school. But if you want just a quick and honest sample, just grab one of the lunch periods. And yeah, maybe lunch period 1 prefers things slightly different than the kids in lunch period 2. That would be which type of variation? Sampling, right? Just the luck of the draw. But all things considered, it should be fairly equal. So that one kind of gets at those 3. Observation, experiment, and then surveys, it kind of broke it up. Are we surveying the entire population, which is very difficult to do, really? I mean, you could survey every kid in the school, but it would take a while and some hunting people down. So people will just grab a random sample survey and use that as a way to predict the entire population, which is all stats is about. It's used to predict. Okay, flip to the back. This is one of the many ways that scientists, I guess, for lack of a better word, actually collect data and ensure that it happens randomly. So there are 10 people, I don't know, on a basketball team. And there are their 10 heights. We're going to assume this is the entire population. This is every kid on the basketball team. So not that averaging 10 heights would be hard to do, but let's say we wanted to take a random sample of 5 of them. Okay, realistically, there's 1 million people that we want to know the average height of, and we're going to take a random sample of 500 of them. But on a smaller scale here, so we can wrap our head around it, the entire population is the 10-person basketball team that we're looking at, and then they're all their 10 heights. So if we only wanted to take a sample of them, there's a random number table, and I gave you one of those below, used to randomly select 5 heights from the list. So we want, the heights are all 2-digit numbers. Are we good with that? Okay. And we want to use this random number table starting at row 7. 1, 2, 3, 4, 5, 6, 7. So, let me back up. We have person 1 through 10. So we want to assign everybody a 2-digit number. There's person 1 would be 01, person 2 would be 02, 03, 04, 05. And if we start on a random number table, this is person number 89. We don't have a person number 89, so we go on. This is person 79. We don't have a person 79, so we go on. This next segment of 2 digits would be person number 33. We don't have 33. 43. This is tough because we only have 0, whatever, but 43, 78. Here we have person number 8. So we're going to use them as one of our 5. Then there's person number 73. We don't have that. Here's person number 5. 05. We're going to use them. And this table, albeit as, random, is, could you agree, we're not biased? We're not all picking person number 7 because 7's our favorite number, right? We're just going to use this random table and whatever comes up. So we've got 65, no, 22, no, 78, 15, 52, 24, 66, 81. These are all thrown away because we don't have these numbers. 62, 7, there's person number 7. 11, 69, 89. This is just tedious. Person number 0, we don't have that, unfortunately. Bummer. 28. Here's person number 8 again. What do you think we do if we get the same person again? We throw it out. You just go past it. 27, 53. Nathan, what were you going to say? Correct. Yep. Yes, because all of we've been assigned 2-digit numbers. If you were pulling from 500 people and everybody had a 3-digit ID number, you'd be pulling from strings of 3. Okay? Correct. Absolutely. Yep. So if I just go quickly, I'm going to eventually get to person number 1, and I need one more. What's going to be my next one? 03. So there's my randomly picked 5 people. Now, you might say, well, why wouldn't I just put 10 people in a hat and pull out 5 of them? That would be completely random as well. But computer software generators do this stuff for scientists to pick their samples, so that's kind of why we're showing you this. There's automated computer systems that will do that. From this, it wants us, just from our sample of 5 people, I'm going to calculate the average height. You don't have to do this with me. 70 plus 60 plus 65 plus 58 plus 62 divided by 5. Our sample mean says the average is 63. Now, the sample mean notation is that. That's our sample mean. Just because we can, because we have our entire population, I'm going to tell you our population mean. That's the symbol, this little cursive U, is for the entire population of all 10. So I'm going to do that just to see how accurate our sample was. Is it going to be exact? Probably not. Is it going to be fairly close? Should be. Okay? Just luck of the draw, we happen to pick shorter kids, it looks like. But the actual team's average is 65.6. Okay? Exercise 4 is just a string of 3 digits here. So to Nathan's point, there were 780 students. So student 1 would be ID number 001. Student 2 would be 002, all the way up to 780. After which, I don't have ID numbers. So when I go through, this would be person number 278. We would hold on to that. This would be person number 167. We would grab that person. The next one would be person number 841. We don't have that person, right? You don't have person number 841 because we only have 780 people. So you would ditch that and move to your next string of 3. Okay, so I don't know how often a random number table is going to come up on your region, but it's something